Hi guys, Buildzoid here, and this will be my attempt at a quick overview of the EVGA Epower V. And the reason why I'm saying attempt is because we all know I'm really bad at making quick videos. Second of all, because it doesn't make sense for me to try to go super in-depth on this, because there is a 28-page PDF from Tin, who's a engineer at EVGA who actually worked on this thing, detailing every single feature of this and all of the functionalities in as much depth as you could really want. So, if you want the details on this, you're gonna have to, you should go read that PDF instead. I'm more here gonna just sort of do a general overview, talk a bit about what it is, what I like, what I don't like. And the only thing I don't like about this, I'm just gonna be right off the bat, is the price point, which luckily I didn't have to deal with because EVGA actually sent this to me, and I do get to keep it because once I use it, they're definitely not gonna want it back, just because of the nature of what this is. But this is a really, really cool piece of extreme overclocker equipment because this is what is known as a power board, and it's essentially a standalone VRM. And this is one of the best implemented standalone VRMs pretty much ever, as far as I'm aware. Because this one just takes the user interface on this one doesn't suck, unlike on all of the other ones. This one's really this one's actually easy to use. It has a ton of features built right in. I still don't agree completely with how some of them are implemented, but they're all present. Yeah, it's a standalone VRM, and why would you actually want one of these? Well, essentially what the purpose of these is to replace inadequate power circuits on various GPUs, and these were kind of like the height of their usage was really around the GTX Titan Kepler and the GTX Titan X Maxwell. And the reason for that is both of those cards had really bad reference PCBs. Like, there's no real way around it. Those both had absolutely just inadequate reference PCBs, especially for liquid nitrogen overclocking, where like the GTX Titan Kepler, the only way to get it to like 1.5 gigahertz without replacing the VRM was to cool the VRM with liquid nitrogen. That has a whole bunch of negative side effects, which further like decrease your overclocking range. So, not an ideal situation in terms of overclocking one of those cards, but a couple people did it when an ePower wasn't readily available to do it properly. And then the Titan X Maxwell was basically the same thing, where the card was capable of pushing, like a Titan X Maxwell and even a Kepler Titan would easily average, say, 1,000 watts of input power consumption. So the output of the VRM would easily be averaging, say, 500 amps. And the Kepler Titan had the reference Kepler Titan had a 6-phase VRM, good for like 360 amps. So obviously that didn't bloody work once you put it on liquid nitrogen. And then the same thing basically applies to the Maxwell Titan, where again, like the card could go well over 1,000 watts if you shoved enough V-core into it, and it would scale that far. Those cards would scale all the way up to like 1.75 volts in some cases. But at that point, your VRM, if you were on the reference VRM, well, it would have exploded about 150 millivolt, well, 250 millivolts earlier, because it just wasn't able to keep up with the power demands. So the solution to that problem is just replace the entire VRM with something like this. And this is, and there's a bunch of these out there. There's been a bunch of these. They're not currently in production. As far as I'm aware, this is the only one you can currently buy, which is really unfortunate, because this is $250. But in the past, like Galax had a Hall of Fame power board, which was a single output 16 phase. Before that, EVGA had a Red ePower Classified that was a 14 phase single output. There was also the EVGA had like some other ePowers that they had. There was a bunch of non-retail ones. There was some that you could sort of buy on the EVGA store. Gigabyte has what is known as the G Power, which was I think that's a 24 plus 4 plus 4 phase setup with triple outputs. Asus has I think they have both a 16 phase and an 8 phase power board, but like Asus keeps these things like super internal, so very hard to get any information on them. So Yeah, and those never actually were purchasable, and the Gigabyte one was the same thing. Like the only way to get the Gigabyte one was if you knew somebody that worked at Gigabyte. Luckily, EVGA is nice enough to allow you to buy one of these very limited run devices. The ePower, the red ePower, the predecessor of this one, was only produced like a couple hundred units. So, like very, very limited volume. And that makes these things rather expensive for what they are. This one right here is dual output. You're looking at a 12 plus 2 phase VRM. So you have a main vCore output and a vMem output. Of course, you can use them for just about anything that, in that voltage range, because this is just a it's a 12 volts to low voltage converter, basically. And the voltage range for the vCore output, so the 12 phase, is from 0.6 volts to 2 volts, and the output for the 2 phase for the memory, or intended for memory, is 0.6 volts to 2.3 volts, which basically means, if you have a card where your memory VRM works, but you've e-powered the vCore and it killed your memory controller rail, you can actually use the memory rail as memory controller, because the memory controllers normally run around 1 volt or lower, and this goes as low as 0.6. So you can run the memory controller off of this. I've also seen in the past, like there was some cases where people would have rails on cards which were just like awkward to get control of, and they just use the 14 phase e-power, and it's just like, yeah, this was originally a single phase. It probably wouldn't have blown up, but figuring out how to get working voltage control on it was too much of a hassle, so 14 phase VRM in place of the single phase. You can also kind of use it for repair, because if you have a VRM that's misbehaving or not functional or broken for any reason and not repairable, you can just replace the entire VRM with one of these lovely things. So that's kind of the, but the primary purpose is basically replacing the stock VRM on cards with crappy stock VRMs. Yeah, so I don't currently have a plan for what to use this on yet, because this is way too nice for me. I don't know, maybe if maybe once I feel like I'm finally finished with all of my Fury X's, I'll try smack one of the, try put it on a Fury X. But I'm really not sure what I'll use it on right now. But we can still have a look around it. So, has 3 6-pin power inputs, so this is good for at least 1080 watts if you're on 18 gauge wiring. If you're on 16 gauge, then it goes way beyond that. Also, it's worth noting that 10 amp, like those current ratings, are assuming a long-term runtime. If you're only doing a couple minutes and you have airflow, you can actually significantly exceed the current rating of any of these connectors, because really the current limit of a power connector is mostly, is it going to melt? And if you're actively cooling it, well, it's not going to melt because you're cooling it, as long as your cooling is, strong enough. So that's kind of, but basically this can deliver over 1,000 watts of power depending on, if you need it. That's the main thing, because obviously if the card doesn't need 1,000 watts, you're not going to move 1,000 watts. But it can support up to that kind of power output. Next to that, you get a USB Type-C connector, which is really, really cool. This is actually one of the things I really, really like about the ePower 5. You can control it over USB. With a lot of the other power boards, you're stuck basically, you can try control them over I2C, except you never have a register map, ever. For the voltage controller, like the high-end voltage controllers that are used on most of these power boards from International Rectifier and such, they don't have public register maps. So good luck getting any advanced voltage control on those, because there's 127 registers on one of those, and if you don't know which register does what, you're kind of screwed. So, that kind of sucks. And so a lot of power boards, basically, you're stuck with things like there's a dip switch that you can use for voltage control, or sometimes you'll have to actually hard mod the power board, because like the Galax Hall of Fame power board has a stock voltage limit of 1.65 volts. Like, it doesn't go past 1.65 volts, which is ridiculous, because like there's GPUs that scale way beyond that. And I guess Galax with the Hall of Fame power board basically intended it for the Pascal series of GPUs, because those don't generally scale past 1.6 volts at all. But Like the thing is like I'm probably gonna smack this on like a 28 nanometer card, or even maybe a 40, 40 nanometer card, or even older than that. I have a GTX 480 I plan to e-power, so really having these low voltage limits doesn't make a lot of sense for these. But luckily this one, you have, zero point 0.6 to 2 volts, so full voltage range, and you do get the control over USB. Also, if you have the EV bot thingy, I don't really know what to, controller, there, EVBot controller. There's an EVBot port on here. There's no dip switches anywhere to be found, which, the predecessor of this had 4-channel dip switch with 4-channel vid, and basically, I mean 4-bit vid. There, that's what I was looking for. And the downside to that was, well, it also tops out at 1.6 volts. I really don't know why, like, the stock physical limits on most of these power boards are like 1.6 volts. It's just like, I'm pretty sure I'm pretty sure most people would want 2 volts minimum. If you were e-powering like an AM3 Plus motherboard or something, you'd actually want more than 2 volts. So yeah, I'm not a fan of like a lot of the older ones. They'd have really low voltage limits, and if you didn't have an EVBot controller, you'd be kind of screwed. So this one gets rid of that because it's controllable over USB. Another cool feature is that you actually have voltage readouts built into it, so they're right on the board. You have some buttons for controlling it if you don't want to use the USB port, but I'd say just use the USB port. Like, seriously, that is so much better than, like, because the thing is, this is going to be like, normally this is going to be sitting in a test bench roughly like this, right? And you're going to be reaching into that test bench, trying to push buttons, possibly on a running system, which is just like, that's just generally a bad idea. So, the fact that they've made it work over USB is really, really cool. That also added a bunch of cost because it needs a microcontroller now. You can't just, use the standard interface of the voltage controller itself. So there's a microcontroller on here for that. There's 2 3-pin fan headers. These are very high current out. These are rated for, I think, 3 amps or 2 amps. Basically, they're meant to support, high RPM delta fans, because if you're actually pushing this to its limits, then, which, let's take a look at the actual VRM under here. If you're actually pushing this to its limits, this will produce a lot of heat. How much heat? Well, for the VCore VRM, you're looking at a 12-phase, and EVGA specs that 12-phase to go only up to 600 amps. And the reason for that is they're using International Rectifier 3575 power stages, and to control them all, there's International Rectifier 3599 doublers, because obviously you can't buy once upon a time, there was 12-phase voltage controllers. Currently, none are available. So basically, the voltage controller on here is a 6+1, is an IR3595 running in 6+1 phase. That's then doubled through the IR3599s. I'm not a fan of the 3599. On the flip side, I'm not aware of any other doubler from International Rectifier. So, the problem with the 3599 is it's really, really dumb. It doesn't do any current balancing, which basically means you have slightly reduced VRM efficiency compared to like a fully, properly balanced VRM. You have you might have slightly worse voltage regulation on the output because, it doesn't have smarter voltage, doesn't have smarter doublers. Essentially, it's still a 12 phase. Like, there's still 12 PWM signals. You don't have more than one phase turned on at the same time under steady current, under steady output. On transients, it can respond as normal. And so you get all of the benefits of like the reduced input ripple and the reduced output ripple. But it's, there's smarter ways to build a 12-phase, like, say, what you have on an EVGA X299 dark motherboard with the Intersil ISL 69138 and the 6617 doublers. Those will actually do full current balancing for the phases, and they'll basically make the VRM look very much like a 12-phase. Whereas this is like it's interleaved, it's just not balanced like a 12 phase is. So it's balanced and it basically groups it too. And I'm also not a fan that they've gone for like a 6+1 phase here, because like this chip does support 6+2 phase output. So they could have totally done a 6x2 for the 12 phase V core and then +2 for the memory. But the memory is also doubled with a 3599. Ultimately is probably not that big of it. Like, it's not going to cause any real issues probably. So yeah, it's just, it'd be better if it was properly current balanced. Marginally better, but better nonetheless. You know, probably not better enough to even notice the difference on an oscilloscope, but potentially still better. Basically, with these components, EVGA is speccing this VRM at 600 amps output across the full voltage range, because if you actually go to the 60 amps output of a 3575 that the 3575 is spec'd for, which would make you think, okay, so we have a 12 phase, there's 3575s in there, they're rated for 60 amps each, 12 times 60 is 720 amps. EVGA is speccing to 600 amps because that 720 amps current figure is actually specced at 1.2 volts output and 400 kilohertz switching frequency, and I think 7 volts gate drive. And EVGA is not driving these with 7 volts because that would need another buck converter, and there's already quite a few of them on here. So basically, there's 2 little voltage regulators down here, which exist basically to provide 3.3 volts and 5 volts to the power board, because I think the 3595 runs off of 5 volts, and that microcontroller might run off of 3.3. So you can't really, like, you don't get the full efficiency of the 3575s. The other thing is the 3575 is rated for that 60 amps really at just 1.2 volts. And if you crank up the voltage output to like 2 volts, the amount of heat it produces for any given current increases by, if I remember correctly, roughly 40%. So at 600 amps output, 600 amps output, 2 volts on the output of the VRM, you're going to be looking at over, say, 126 watts of heat. Whereas at 720 amps, 1.2 volts, you'd be looking at 144. So EVGA basically is taking into account that, even with a lot of airflow and the exposed power planes here, so that's done for heat dissipation, have a pretty substantial heat sink. I mean, it could be bigger. It could always be bigger. But it is reasonably substantial, and it has actual finnage, unlike most motherboard heat sinks, because this actually needs to work. If this didn't work, you couldn't break world records with it. Whereas if a motherboard doesn't work, well, it might just shut down on you, and, big deal. But so, EVGA is basically taking into consideration that there's not really reasonable to expect this VRM to stay below, say, 125 degrees Celsius if you, even with a lot of airflow and everything they've done to cool it, if you're pushing, over 600 amps at 2 volts. And their peak output is actually rated at 1.85 volts, 620 amps. And yeah, that's kind of the current ratings on this, and it's partially because, they don't have the full gate drive that could slightly improve the efficiency of the power stages. But the main issue is that these power stages, they're rated at 1.2 volts, and at 2 volts, they produce way more heat than at 1.2 volts. Because otherwise your efficiency would just get kind of ridiculous if your heat output didn't change with output voltage. So, yeah, it's very powerful though. Like 600 amps is still way more current than you're really going to need for any GPU. The only scenario where 600 amps would be inadequate is, say you wanted to power board, wanted to use one of these on a GTX 590. That would be a terrible idea, because a GTX 590 has 2 GTX 580s glued together, and a GTX 580 core on liquid nitrogen can easily pull in excess of 300 amps. And with 2 of them in parallel, you're going to have like 600 plus amps, and at that point you're going to start overloading this. But if you're hell-bent on breaking this thing, they've given you all the necessary switches to allow you to do that, because there's a bunch of dip switches down here, which are so you have some voltage offset settings. You can disable protections. So if this shuts down on you because of overcurrent protection, you can disable that. And then it's just going to keep running until it catches fire, basically. Unless you, cool it really, really well. but probably until it catches fire or has some other kind of issue, because there's, it's not just about the MOSFETs at that point. You might exceed the current rating of the inductors, and then your voltage output is going to just go kind of out of whack, and you're going to have a bad day regardless, even if the VRM is relatively cool. They also have forward voltage sense. That's better explained in the 28-page PDF. So, as well as droop settings. So that's all covered there. And that's also a really, really cool feature because, on some cards you might actually want voltage droop, or you might want absolutely steady output voltage, and, you want your voltage output voltage reference against the actual back of the GPU core, and not the, not the output of the power board, because there's going to be a voltage drop across the power like the connection you make from the power board to the GPU, and then through the GPU's own PCB, there's going to be a voltage drop across that. And, well, if you set 1.6 volts, you might get 1.6 volts here, but by the time it gets to the GPU core, it might be like 1.45 if you're on a really, really high current draw GPU. And that's, you don't want that, because that's limiting your overclocking because your voltage is dropping down. So, so that's kind of cool that they have those options, though that's available on most power boards, and you can always mod it onto them, assuming you just have the data sheet for the voltage controller. Well, even like the data brief, where you just get the pin out, you can usually work off of just that. So those are cool features. Yeah. And I'm actually glad that EVGA rates this at 600 amps output and not 720 amps, because if you look at the Galax power board, the 16-phase they have, they actually spec that, they don't spec it, but they advertise it as 960 amps output. And they're using International Rectifier 3055s, which are basically the cheaper, less good version of the 3575, because the 3575 has the exposed drain, which massively improves their thermal dissipation, whereas the 3555 is just your standard package, and other than that, it's basically a 3575 without the extra fancy packaging for better thermal performance. So Galax, their power board, they're like, oh yeah, I can do 960 amps output. If you actually do the math for that 960 amps output, you're looking at least 200 watts of heat. More if you start factoring, high voltages into that. And, well, that's not really viable. So I'm glad that EVGA is like, okay, we have these 60 amp power stages, but we're not just going to do the usual thing of add all the power stages up and call that maximum output current, because it doesn't work like that, because they're going to overheat. Because there's going to be, if you can't get rid of the heat, it's just going to build up until something breaks. That's the vCore output, which is neat. Memory output is rated, spec'd by EVGA for 90 amps, which is actually underrated even more so than the vCore. But this goes all the way up to 2.3 volts output, so I think that's why they're speccing it a bit lower there. And nonetheless, you're never going to need 90 amps for, I can't think of a memory controller or a memory system on a GPU that would actually pull 90 amps. So that's not a massive concern. Though I guess if you wanted to powerboard a motherboard and you wanted to run maybe a Northbridge off of it, Northbridge probably, nah, otherwise they'd need much bigger heat sinks. So, yeah, basically this is plenty powerful for any minor rails that you could possibly want to power with that. So, power-wise, very powerful. Feature-wise, control-wise, very, very nice. You get full software control, not stupid dip switches and limited voltage outputs. Now, fully featured in that department. And the other thing that EVGA has really, really upgraded over some of the past power boards they've put out is the actual layout of the connections. So here we have a R9290X that has a massive short circuit. Well, I attempted to remove it. When I got the card, this had a basically 0 ohm short circuit on its 12 volts from 12 volts to ground right here. It now has a 4 ohm short circuit from 12 volts to ground, which is still a short circuit. So I still, basically, and digging into the PCB more and more wasn't really going anywhere. So I decided, you know what? Instead of trying to fix the short circuit, we will just go around the short circuit, because that's much easier. And so I basically prepared this card right here for a power board. idiot me kind of got into the flow of things and removed the memory VRM as well as the whole vCore, which was unnecessary, because what actually happens with these with 290Xs is you mod vCore, which kills memory controller down here. So that's your auxiliary rail. That's controlled by this chip over here. So and that chip also controls vCore. So once you screw up vCore, this chip's going to start complaining, and it's not going to give you the memory controller voltage. But some idiot also removed the memory rail, which is powered by an NCP5230, and I probably could have fixed that, but once I removed it, it's like, that's not coming back on. Those are international rectifier direct FETs. I'm not going to attempt soldering those back on. That's just a massive pain. If I had hot air and new chips, I'd try it, but at this point. So how would you attach one of these? Where's the big advantage with it? So like the previous e-powers and like most e-powers, you get a nice big ground tab on the back here. You also get, which this is new because this is one of the few that's dual output. You get the memory output right here. Then you have another ground tab up top here. And if we flip it over, this is where the big change from the previous e-powers comes from. They've actually given us a ground tab. Well, it's not really a tab at that point, but you have a ground plane right here. And of course, this all is vCore output. Then you have another ground tab right there. You have a ground here. You have a grounding spot right there. And then you have the memory output here again. And this is actually like my favorite part of the ePower 5. Like all the controls stuff, that's cool and all. But not having a massive pain grounding the damn thing is a huge, huge advantage in my opinion. Because the problem is, if we ignore all the front-facing grounds that EVGA has made available, you'd basically be stuck grounding off of this. And, well, if you attach this through the shortest possible connection from this vCore edge to the vCore power plane, which is most easily accessible right here, you know, where the inductors of the original VRM, you know, outputted to, that ground plane is like, that rear ground is not accessible. Like, you're just not getting there in there with a soldering iron. You're not going to be grounding anything. And the other issue with that is like, okay, so you might think, okay, I'm going to be clever. The LN2 pod only needs to be in this area. Well, this area. And so I'm going to just smack this on like that, right? That's going to be, that's a great idea. And then you have an easily accessible ground plane over here. The problem is all of these grounding points sort of to the right of the VRM are irrelevant, because the good strong ground plane is designed, like the way the power plane of the GPU is designed is that you need to pass high current from the input of the vCore power plane to the core, into the ground, back to the VRM. There is no reason for, say, this screw hole over here to have a, you know, good electrical connection to the ground that goes to the GPU core. And that is a massive, massive problem if your only ground plane is on the back of the board, you know, on the back of your power board, because there's really no good grounding spots anywhere. I mean, you can try grounding off of the grounds that go to the low side MOSFETs. You can try grounding off of the 12-volt multi-layer ceramic capacitors in the area. You know, you could maybe... This screw hole is probably irrelevant just because it's a screw hole and they're generally not electrically connected very well at all. They are ground, but like they have a lot of resistance to them. So there's no point trying to ground off of those. And that makes it, you know, that leads to a lot of voltage drop. So on, say, the Galax Hall of Fame power board, they actually take care of that, where you have a strip of ground and then you have the vCore edge. The ePower here doesn't quite have that. You have much larger vCore tab and then a little middle ground right here, bit of ground there, bit of ground there. But that's still a big improvement over the older ePower, because that thing was vCore. Like this entire side was just vCore, and you'd basically be stuck creating your own ground planes between the output filtering capacitors. Which you can do, but it's messy and it's annoying to work with, and like it's just less than ideal. This is much more convenient to work with. The end result is, if you actually wanted to hook something like this up, is you would basically go for something like, have it like this, and you just go vCore edge to the various inductor inputs. How you bridge that, you're going to use either very high gauge wire or copper plate, or solid core wire. If you have a solid core wire and it's, short, then it can carry a lot of current, even if it's not necessarily as thick as a multi-core wire of a lower gauge. It can still handle more current just because it's a solid conductor instead of a whole bunch of strands. But you'd basically hook up your V-core, and once you're done with that, well, you can start grounding like crazy because you have all of this lovely accessible ground up here. So you can ground off of that to right here, because there's a ground plane right here, and we know there's a ground plane because that capacitor is hooked into that. You can also just take a multimeter and check that that's ground, the side of these multi-layer ceramics over there. So you'd scrape away the PCB, hook up some, low gauge wires for ground right there. You could do that again here and here and here and really just about everywhere. Like there's the cool thing about the 290X is actually that you have it basically goes ground, V-core, ground, V-core, ground, V-core. So it's like it's patterned like that. So you can actually attach a lot of ground planes really easily just sort of into this capacitor bank right here. And you'd pull all of those grounds, like you just pull the ground from the nearest ground tab, which would be this one for a lot of the ones in this area, and then this one for everything down in this area. And that's just much better than some of the previous power boards where you basically, you couldn't do that. That's actually a huge advantage. It's just much easier to work with because of that. And then for memory output, so you can obviously hook up the memory output to the, at that point you're looking at a pretty long wire, but hey, memory is not that high current. You're not going to get that much voltage drop across it. Also, if you're on the back, let me just sort of if you're on the back here, then, you can pull this ground to that screw hole. There's probably some ground planes in this area that you could probably ground this off of. You could pull memory to, I think memory output is right here. So you could pull a wire, another wire just over, well, a couple wires maybe even. Depends on how good you are with your soldering iron. You can pull some more connections over there. Basically, the new power plane layout that this comes with is so much better than a lot of the other power boards. So this is like the most refined power board you could possibly ask for, because you have proper controls. The USB Type-C is really cool. You can actually update the firmware on this, and if you wanted to, you could, if you had enough information, you could do things like program custom load lines, change the switching frequency of the voltage controller, do everything over that USB header right there. So that's really cool. You have the voltage readouts built directly into it. You have the Probit connector for hooking up your multimeter, which is standard for basically anything extreme, anything EVGA puts out that's even remotely extreme overclocking targeted is going to have one of those Probit connectors, which is pretty neat. That is a really good way to implement voltage read points. Even though they don't always hook up all the relevant voltages to the actual connector. But this is a lot better than what a lot of motherboards do, where they have solder bumps, and it's just stab these solder bumps with your multimeter while the system is running. This is great fun. Oh, and to make it even easier, we put them right next to the 24 pin, the biggest, fattest, most obnoxious wire in the entire system. Yeah, that's where we put the solder bumps for measuring voltages from. So, yeah, this is just it's not the most powerful power board, but it's definitely the easiest to use power board, I'd say. And that's that's a big deal if especially if you, because the thing is, if you don't mind pulling it off of multiple cards, because that's the main problem I have with it, is this is $250 most of the time. It did go on sale recently for $150 or $100. And even then, it's really expensive because, a GTX 480, if you want to bench a GTX 480 with one of these, a GTX 480 is $30 or $50, and this is 5 times as much as a GTX 480 at that point, which means, it's not exactly unless you have money to throw around, this is not exactly something you just stick onto a card and leave there, because it's often worth more than the card you're attaching it to, which is even true for this 290X right here. This is roughly half the price of one of these. So that is just that's my main complaint for it. It's it's really nice. It's really expensive, and there you have a good reason for it. As I said, the previous ePower, the red ePower Classified, they made a couple hundred units of those, and those weren't anywhere near as nicely featured as this thing was. Like those, you know, they had a 4-channel dip switch, and they went up to 1.6 volts, and if you didn't have an EV bot, screw you, you're gonna have to hard mod your voltage control basically, or you're gonna have to, you know, hook up a Raspberry Pi, and then there's like a program that you can run on there that emulates the functionality of the EV bot. But like that's still really janky compared to, you know, a USB port that plugs into your computer, and then, you know, you can like the thing is you can run that USB port off of the machine that you're actually running on LN2, or you can run that into a laptop or whatever other system you want to. So this is just like much more refined essentially. Like it does the same thing, and you can definitely, you know, get by with the other power boards, but this should be so much easier to work with, and so much less of a hassle than the other ones. And that's, you know, that counts for a lot, I guess, because attaching these things is already a pain. Like this is not something you just kind of, you know, this is not your usual volt mod, or, you know, any other, like, you know, the little volt mods you can do on the PCB without replacing the entire VRM, those are relatively easy. For something like this, where you're talking like the soldering iron you use for your main power plane connections, you're talking minimum 80 watts. And say Der Bauer, who's done a ton of GTX Titans with e-powers, he uses a 150 watt iron. I use that same 150 watt on recommendation from him. And even with that 150 watt, it sometimes, like, some of the bigger power planes can still, you know, some of the heavier cards with the bigger power planes, like, they still take a while. So, you know, this is not your, like, this is hard enough to do with when the power board is bad. So when the power board is this nice, you know, that definitely counts for something. The downside is, like, a lot of the time this is going to be worth more than the cards. And so you're going to be potentially moving this card to card to card. And, you know, that'll leave you kind of in an awkward situation where if you, like, have a GTX 480 that has a really, really good core and it clocks really, really high on liquid nitrogen, well, like, you're, you know, if it clocks really high with one of these attached, you're kind of stuck leaving this on that card unless you want to, you know, reattach it every time you want to rebench the card. So, yeah. But nonetheless, this is a really, really cool piece of extreme overclocking gear. And yeah, I just can't, like, I'm probably going to use it on this 290X, because I tried to fire this 290X up off of one of my, well, chopped off VRM from random GPU that stopped working power boards. That did not work, and so I'm going to attempt it again with a better one, and we'll see if, you know, with a known good power board, if it'll work. And yeah, if it does work and it you know, overclocks properly, then I guess we can run this card on liquid nitrogen eventually, because I've run out of liquid nitrogen. So yeah, and we can upgrade it from the stock 5 phase to a beastly 12 phase. And then potentially I might, like, because I don't have any plans to, like, overclock a Titan anytime soon, and unfortunately the more recent NVIDIA reference cards actually have really nice reference PCBs. Like, I wouldn't like, I don't really see a point of trying to attach something like this to the GTX 1080 Ti, just because the 1080 Ti reference PCB is really not that bad. Okay? Like, yeah. Like, it's really not that bad to start with, so I don't see the point of trying to attach something like this to that. And I actually even talked to Kingpin about it, where I was like, so I'm getting the ePower 5, should I stick it on the 1080 Ti? And he was like, no, it's not going to help. Though, funny story, EVGA actually uses these internally for Kingpin Edition GPU development. So this, like, the Kingpin Edition prototypes are built with these. And then once they figure out how much VRM it actually, like, how much power this has to move, that's when they start designing the VRM for the final Kingpin cards. So the actual retail cards. So this is a really, really cool piece of tech. It's just kind of really expensive. So, yeah. But, and you can't even say you get what you pay for, because it's so low volume. if it was, you know, higher production, then it really wouldn't have to cost that much. But since it's a couple hundred units at a time, then yeah, this is going to be expensive. But it is very nice, you know. I am very happy to have this. I just don't know what I'm going to stick it on permanently. Maybe a Fury. I don't see a point in putting it on a Vega, because a Vega has a Vega comes with a 12 phase. So going from a 12 phase to another, like, especially because that's already an international rectifier 12 phase. So it's like, it's not even remotely an upgrade, because it's basically going from one 12 phase from IR to another 12 phase from IR. Not really much progress right there. But and it feels kind of like a waste to stick it on some old junk card, but that's really where these kinds of power boards shine these days, because as I said, the reference cards are getting really, really good. Well, not really, really good, but not completely garbage. Like, not garbage enough that you'd necessarily need to e-power them. So, or benefit even from e-powering them. So, yeah. But nonetheless, you know, if you're into benching old junk hardware and you don't like hunting down Lightning editions, then, or like Lightning editions, Kingpin editions, that kind of thing. If you don't like hunting down specific GPUs, this is a good option, because, you know, if you're good with a soldering iron, you can just move this card to card to card until it breaks down eventually. But you can probably go through. Like, this is probably capable of blowing up more cards than you necessarily, you know, want to. So, yeah. I'm really happy to have this to add to my collection of power boards. Now I just need to start using them. Though it has at least freed up one of the other power boards, because it was like, I don't like using up all of my resources, so it's just like, need to stockpile power boards so I don't have power board shortage one day, and now it's like, well, now I have more power boards than I have dead GPUs. Okay, so, oh damn, I've made this video really long. I'm not reshooting this. I've been trying to shoot this video for like 2 days now, and it just keeps rolling over. So that's it for the video. Sorry for boring you to death if I have, and well, at this point you're dead, so I don't know why I'm apologizing. But if you liked what you saw, then you can like, share, subscribe, and heard mostly, because there's not really much that I showed you. Yeah, you can like, share, subscribe. You can leave any comments, suggestions, questions down in the comment section below. And if you'd like to support what I do here with actually hardcore overclocking, I have a Patreon, PayPal, and t-shirts. You can find a link to all of that down in the description below if you'd like to help out the channel, so that I can acquire more crappy GPUs with crappy VRMs to use this on. Because currently I'm actually in a shortage of crap GPUs. So, I mean, I do have a GTX 480 and two 590s, but this really isn't meant for a 590. Like, I have plans for the 590s, but this is not involved in those. So, yeah, that's it for the video. Thanks for watching, and goodbye.